Hello, my dear students. Welcome you all to Shri Jayendra Rank Zone classes. I am your mentor and your friend for the subject chemistry, and I will be taking organic chemistry. My dear students, today we are going to start with the study of aldehydes, ketones, and carboxylic acids. In this lecture, we will study how to write the common names, IUPAC names of aldehydes, ketones, and carboxylic acids, how to write the structures of the compounds containing functional groups, namely carbonyl and carboxyl groups, and their physical properties. So let us start with aldehydes, ketones, and carboxylic acids. So in the first slide, we are going to discuss aldehydes. They can be represented as and ketones can be represented as R dash, where R and R dash they can be equal and they cannot be equal. I mean, it can be symmetrical as well as unsymmetrical, right? As in case of ethers. Carboxylic acids, they have carboxyl group. For example, RCOOH. Derivatives of carboxylic acid includes acid halides, where X is halogen and it can be Cl, Br, and I. Then come acid anhydride, acid anhydride. Next, we have esters as the derivatives of carboxylic acids. Amides, okay. So these are the different compounds. All the above compounds, they have one thing in common, presence of carbonyl group. Which makes these category of compounds to come up with high reactivity. Okay, all these compounds, they are found in organic world. They play an important role in the biochemical processes of life, especially when we talk about the uses of aldehydes and ketones. They are very much used to add fragrance and flavor in the nature. Like for example, vanillin. It is extracted from vanilla beans. This is the compound. Okay. Then we have salicylaldehyde. Then we have cinemaldehyde. Cinemaldehyde is an alkaloid which is present in a very important mouth freshener, cinnamon. In common words, it is also known as elaichi. So all these compounds, when we talk about spatially aldehydes and ketones, are used to make perfumes, deodorants, food products, and medicines. Formalin is also used as a preservative. Formalin, which is 40% dilute solution of formaldehyde, is used as a preservative for biological specimen. Okay. Acetone is used as a very good solvent. It is also used to prepare adhesives, paints, resins, plastics, and fabrics. Okay. Now we are going to study about the nomenclature and the structure of carbonyl group. When we talk about aldehydes, if you are writing IUPAC name, then we use suffix "al" and the prefix used is "aldo". When you are writing common name, like for example, the common name is acetaldehyde and the IUPAC name is ethanol. Okay. For ketones, when you are writing common name, the common names of ketones are derived by naming two alkyl or aryl groups bonded to the carbonyl group. Like for example, the common name is acetone. Okay. While the IUPAC name is propanol or propane 2-on. Okay. There are some Greek letters which are used like alpha, alpha dash, beta, beta dash in writing the common names. Like for example, this is a functional group. The carbon attached to the adjacent to the functional group is alpha, then it is beta, then it is gamma, like this. So we have beta bromo, 4 carbon chain, butyryl dehyde. This is the common name. Okay. In case of alicyclic substituted aldehydes, for example, we retain the word carbaldehyde. Okay, so it is cyclohexane carbaldehyde. Okay, we have 3-methyl cyclopentanone. If an aromatic compound mean is attached as a side chain, mean if the aromatic compound is attached as a side chain to the main parent hydrocarbon, now this is known as elect as a side chain, and this is the main compound. So 1, 2, 3. So it is 1 phenyl, 1 phenyl propane 1O. Okay, so these are the different compounds. Okay, if in case both aldehydes and ketones both are present in the same chain, then aldehydes, which are supposed to be more reactive than ketones, are present in same parent hydrocarbon chain. One, two, three, four, 5. So now the ketone will be act as a prefix. So 3-oxo-pentanal. This is the compound. Okay, there is no space. 3-oxo-pentanal. Okay. In case of multiple functional group attached to the carbon chain, like for example, then this is considered to be the main chain. So it is propane 1, 2, 3 Okay, it is done because to give identical treatment to all aldehyde groups. Understood? So this is the IUPAC. In case of carboxylic acids, suffix oic acid is used. Okay, the prefix always not used is carboxy. There is one case of multiple functional groups attached to the main chain. So you will add in the same way propane 1, 2, 3 tricarboxylic acid. Okay. In case of acid halides, the suffix used is alkanoyl halide. For example, it is known as what? Ethanoyl chloride. Ethanoyl chloride. Okay. Acid anhydride. The prefix of acid halide is halocarbonyl. Prefix I will write here. Halocarbonyl. Okay. So it can be written as chloroethanoil. If anywhere prefix is used. Okay. Yes. Prefix uses halocarbonyl. Acid anhydrides are basically prepared by condensation reaction of carboxylic acids. The word acid is used, ethanoic anhydride, because it is the anhydride of ethanoic acid, ethanoic anhydride. Okay. Esters, they are named as alkyl alkanoate. For example, methyl ethanoate. The part from the part which is coming from the alcohol is written first, and the main chain goes with the carboxyl part, this part. Okay, so methyl ethanoate. Understood? I haven't told you the prefixes because I have already discussed the prefixes in the IUPAC nomenclatures. Okay, so then come acid amide or just amide. Suffix amide is used. Alkanamide, ethanamide. Because E and A they cannot come together, so I have omitted the E. The name is ethanamide. So this is about the IUPAC nomenclature of aldehydes, ketones, and carboxylic acid. There are some common compounds in case of carboxylic acids you have to remember. For example, phthalic acid. If in case the aromatic hydrocarbon is attached to a side chain having the functional group, and this is the parent hydrocarbon chain, so it is phenyl acetic acid, or phenyl ethanoic acid. Understood? These are the IUPAC nomenclatures. Then we will talk about the physical properties. First, I am going to discuss the physical properties of aldehydes and ketones. As you know, in case of aldehydes and ketones, we have a carbon double bond oxygen. This carbon double bond oxygen basically provides dipole moment, and that is why these compounds are able to make hydrogen bonding with water. So, what you have to remember that lower members are miscible with water, means they are soluble in water. As they show tendency to make hydrogen bonding. But as we increase the number, the hydrophobic nature increases, and that is why tendency to make hydrogen bonding decreases. Okay? Lower members of aldehydes and ketones are gases at room temperature. Okay? However, ethanol is a volatile liquid. Other aldehydes and ketones are liquid or solid at room temperature. Boiling point of aldehydes and ketones are greater than hydrocarbons of comparable molecular masses. Because of dipole moment. Okay. The boiling point of alcohols is more than aldehydes and ketones. Like this. Okay. Sorry, ketones boiling point is more than aldehydes. Than aldehydes. Understood? Then comes hydrocarbons, or we can also include ethers before hydrocarbons. Understood? Lower aldehydes have sharp pungent odor. Okay. As the size of parent hydrocarbon chain increases, carbon number increases, the tendency to escape to volatilize decreases. Understood? And that is why lower aldehydes and ketones they are used for the blending of perfumes and flavoring agents. Now I am going to discuss about the physical properties of carboxylic acids. In carboxylic acids, the lower members are colorless, pungent smelling liquids like C1 to C3. They are colorless, pungent smelling liquids. C4 to C9, they are also liquids having goat's butter like smell. And C10 to C10 plus Bexy solids, which are odorless and colorless. Solubility, lower members are more soluble in, for example, up to 4 carbons, they are highly soluble in water. As the molecular weight increases, the van der Waals force increases. Okay, the molecular weight is directly proportional to van der Waals force. The hydrophobic nature increases and tendency to form hydrogen bonding decreases. And that is why their solubility decreases. Okay, as far as boiling point is concerned, boiling points of acids is greater than alcohols, and that is because of intensive hydrogen bonding, dimer formation. In case of carboxylic acids, they have two more electronegative oxygen atoms. So these two sites are used for hydrogen bonding. While in case of alcohols, we have only one site for making hydrogen bonding. Okay. Dimer formation in their vapor state. As only one site is available. Okay. This is the dimer formation. Melting point of carboxylic acids do not vary smoothly from one molecule to the other. It is, first we can say it is random. Till 5 carbon atoms, okay, is highly variable. If there is a carboxylic acid of even number, carboxylic acid, the packing is strong, the lattice is strong, and that is why the melting point is high in comparison to odd number of carbon containing carboxylic acids. So my dear friends, we have discussed the physical properties, IUPAC nomenclature. Rest, we have to discuss about the uses of carboxylic acids and aldehydes. I will be discussing in the next turn. Till then, bye bye. Take care. Stay safe. Stay healthy.